6 of computer programming, and this topic is 2 L's, loops and lists, okay? Double L. So first of all, loops in Python. So the good thing in Python is that there are only 2 types of loop, okay? There is a for loop, and that's for a specific set of conditions, and there is a while loop, and that's while we're waiting for something to happen, while we're waiting for the condition to be true. And that's it. That's the only 2. So there's a sort of simple flowchart for each of these. We go into the loop, then there's some kind of a condition, and then in the case of a for loop, we get the next item and we check it against the condition, we get the next item and we check it against the condition, and then we're done. When we run out of items, we're done. The while loop's a little bit different. The while loop will keep running until some condition becomes true. Okay? So in a while loop you could have any number of things. You might not know. You might say just keep running this until the temperature reaches 100. Okay? Think about it, a kettle kind of has a while loop built in, doesn't it? It's like you press the button and it's like while temperature is not 100, boil. Okay? Heat. And then when it stops, okay? A for loop wouldn't be very good unless you had 5 kettles. You'd say, while my kettle needs to be boiled, boil kettle. And it would do one, then the next, and the next, and the next. Okay? Very silly analogy. So, here is how we do a for loop in Python. It's dead easy. We just write for, and then some variable, and then in, and then whatever we're trying to loop over, and then what we want to do to the thing. Okay, so I'll give you an example now. So here's a for loop. So we'll set up a string first of all. So my string is equal to hello. Okay, save that to the RAM, and then if we do for item in my string, and then we press colon, and that's going to set us up to go into the body of the loop. So we'll press return, just do print item, and what it'll do is it'll loop over my string and print out each item one at a time. Okay, now this word item is not a reserved word, right? That could be, we can change that. That could be any word. Okay, sometimes you'll see it written in documentation as I. Okay, but I just don't like writing I because, I don't know, just you end up with a program full of I's. So you could write anything there. For elephant in my string, print elephant. It doesn't matter. It's just a variable that the loop's going to use. Obviously my string you need to use the correct name for that. You can't write for elephant an elephant, because then it'll say elephant. I do not know what elephant is. So this is kind of a temporary variable that we set up for the for loop to loop over it. Now we can get the for loop to add things to the letter, like this is a letter, okay, and then if we put a comma here, it'll allow us to just loop over the item saying this is a letter H, this is a letter E, this is a letter L, this is a letter L, this is a letter O. Okay, so we can have all sorts of things. We could say, we could add a letter on. We could if we were doing this with numbers, we could add a number to a number. Anything. The key is that you're going to go over each item in the object one at a time. You're going to pick one bit out and do something to it. So imagine if you had a list of numbers and you were trying to work out what the tax was on them. A list of payments, and the VAT, the tax is 20%. You might say for item in my numbers list, item equals item, and then work out 20%, and then return me the values. So that's the for loop there. So here, there's the example I just showed you. For item in my string, if item is A, print item. Okay. There's another way to do this actually that I'm going to show you. I'm not entirely sure if this is the most Pythonic way to do this, so let me just show you. So we're looking to detect if there's something in my string. Okay, so let's just clear the screen here. So we've got a string called my string, right? Print my string. Okay. Hello. Right. So let's say we want to have a look for something, right? For item in my string, if a in item print found an we'll go for E because there is an actual found an L. Let's say found an L. Okay, and we'll change that to if L in item. Okay, let's run that. See, so what it's done for item in my string, if L in item print found an L. So I think that's a little bit better. That's a little bit more. I feel like that's easier to understand. I'm going to change this slide, to be honest. This is a better way to do it. So hold on, let me just update this because I don't want to give you. So my string equals I am a string. That's fine. For item in my string, if, let's just change this round. If A in item is a better way to do it, I think. And we also need to be able to spell item as well. If A in item, print item. That's better. Oh, pop that around quotes because it's a string value. So that's a better way to do it, rather than if item is equal to A. I just think to me that seems like simpler syntax. For item in my string, so you're almost talking to the computer in English there. You're saying for an item in the variable my string, if the letter L is in that item, do this. Print something out. Found an L. Okay, should be found an L actually, not found and L. Let me just fix that. Found an L. There. Okay. So that's a conditional inside a for loop. Okay. While loops now. The while loop tells the computer to do something as long as a condition is met, or until a condition's met. Okay, so we use this keyword while, and then there's a condition. It's kind of similar to an if statement, but it's an if statement that'll keep going until something happens. Okay, so A here is going to be 0, and while A is less than 10, A plus equals 1, print A. So let me show you this in action. So we're going to make a variable called A, and we'll set the value to 0. And we're going to say while A is less than 10, A equals A plus 1. Now that would be the longhand way of doing it, and I'll show you the shortcut. So let's just do print A, right? So let's run this, okay? Run. So it's going to go to A and add 1 on and print out the result as it goes. Now that is fine, but there's a better way of doing it, okay? And it's the way I've got over on the slide here. So the better way of doing it is A equals A plus 1 is actually just the same as A plus equals 1. Okay, A plus equals 1 is the same. It means add and assign. Add, so get this, add it onto this, and then update the value. Okay, so it's a more enhanced operator. Okay, I call it plus equals. I don't know if that's the right name for it. Who knows? So let's run that. Now nothing's going to happen because remember A is 10 now, so nothing there. But let's just update this. While A is less than 20, A plus equals 1, print A, and there's A up to 20 now. Now, let's see if we've got some slightly more interesting examples. Right, so this variable is sometimes called an accumulator variable, okay? and you'll see this in programs set up. Sometimes the word used for it is count. Okay, so while the count is less than 5, print count is less than 5, count plus equals 1. So if you were maybe sorting over some files and you wanted to group them in 100s, you might say count equals 0, right? While count is less than 100, less than or equal to 100, go and get a file, move it over here. So there's an example there. Notice we can put an else in a while loop as well. So similar in some way, it's related to the if statement. It has a conditional in it. Okay. So that's the first part. 2 different examples of loops. We're now going to look at lists. So in Python, okay, a list is a very, very useful data structure. So far in this course, we've been looking at simple data structures like variables. Okay, so let's just check the type of A. Print, and then do type A. Okay, an integer. Simple data structure. It's a variable. It's got a type. That's it. So a list is a little bit more of a what we would call an abstract data structure, because it has a little bit more. There's a little bit more to it. Okay, it's a type of variable. It's just a list variable. So when we create a list in Python, okay, we're creating a collection of data, and that collection is in order. It has an order to it. And the useful thing about that order is we can say, oh, give me this one, give me the thing at this position. Okay, it's also changeable, so we can change the values in the list. Okay, another word for changeable that's more used in computing is mutable. Okay, mutable, immutable. I prefer to use changeable because people understand what that means. Okay, so here is an example of a list. Dog, cat, horse. Okay, and we set it up with these square brackets like this. Strings need to go in quotes. Items are separated by commas. And then we can just print it out, and it'll print out the items. Now last week we looked at string indexing. Okay, now lists are indexed in the same way that strings are. Alright, so if we want to get an item, we just provide the index number in there. This would give us cat, because indexing starts at 0. Okay, so negative indexing, exactly the same as with a string. We just refer to the very last value as -1. Okay, so my list -1, that would give us horse out there. Okay, then if we wanted to say start from 0 and go all the way along to the 4th position, we could provide it with a range, exactly the same as we did with strings. So bit of a demo on this one. Let's make a list. Oh, it would help if I could work the computer. So my list is equal to, and then to set it up we just do square brackets like that, and then we'll put some values in it. Okay, so we're going to do like red, green, remember the quotes, comma, space, and blue. Red, green, and blue. Let's run that. So we have a list now saved. Okay, and if we do print type my list, we'll see that Python is treating it as a list, which we would hope. So if we do for item in my list, okay, and then print item, it's going to loop over the list and give us each item one at a time, just like it did with the string. So let's go there, red, green, blue. Now we can also just print from the list. We can print, let's just print out one value in the list. My list 0 will give us red because it's the first thing. Okay, so second position would give us blue. Alright, this will give us green. Okay, -1 will give us blue. So we can just call it by the index. Alright, so we can add new stuff to the list and take stuff away as well. Let's go to some examples of that. So there's just some examples of looping over a list. For x in my list, print x. We could change the value of something in a list. I said that they're ordered as in they're indexed and they're changeable, okay? So change the value in the list. Let's have a look at how to do that. So we just do my list, and then we provide the index value. So let's say my list 1, right? Well, let's print my list 1 first, right? To see what it is. Okay, it's green, right? So what we're going to do is we're going to do my list 1 and then just say equals, and we're going to change it to yellow. Okay, run. Now if we print my list 1, it's now yellow. Okay, let's print the whole list out. You can see that that's been replaced with yellow. Okay. Check the length of a list. We can just run the len function on it. Len my list. Just like I'm doing with the type function, you just nest it in. MyList.append will add something onto the end of a list. So just like myString.count, MyList.append will stick something on the end. MyList.insert will put something in a particular position, but you need to tell it where you want it to go. Okay, so if you just want to add it on the end, you can do append, and if you want inserted at a specific position, you can do mylist.insert. Removing items, you can just do mylist.remove, and it will remove the item. You can delete the list with del, and you could also do mylist.clear, and that'll clear all the items out of the list. So a lot of useful methods on the list there. And finally, looping over lists. I already showed you an example of this. So here's an example where I've got some numbers. I'm just going to say for item in numbers, if item modulus 2 is 0, print the list contains an even number. So the modulus, hopefully we remember, is just the remainder after a division. Okay, so if we do, for example, let's work in modulus 4, right? 1 mod 4 should equal 1, right? 2 mod 4 should equal 2. 3 mod 4 should equal 3. This is where it changes. 4 mod 4. So 4 divided by 4, what's the remainder? 0. 4 mod 4 is 0. Now, 4 mod 5, okay, so let's do 5 mod 4, what's that going to give us? 1. Because 5 divided by 4 is 4 and 1 left over, okay? Then 6 mod 4 is going to give us 2. Then 7 mod 4 is going to give us 3. Then 8 mod 4, we're wrapping back around again, is going to give us the same answer as 4 mod 4. 0. Now, notice there's a pattern. It goes 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. When you get... Oh, hold on. Let me just... I think someone's unmuted. Let me just see if I need to mute someone. There we go. So, when you get... when you're dealing with numbers, and you run the mod operator on them, so 8 mod 4 for example, this 4 mod 4 and 8 mod 4, when they give the same result, that's called they're being in the same equivalence class. Okay, the fancy word for it is that they are congruent to each other, but that's a little bit beyond the scope. However, we can use the mod 2 operator to check if a number's even. Okay, so for example, 3 mod 2 is going to give us 1, but 4 mod 2 is going to give us 0, because 4 is even, because it divides by 2. Okay, 5 mod 2, 1. 6 mod 2, 0. Okay? Right. The final thing is breaking a for loop. So when a for loop's running for x in range, you might want to ask it to just break at a certain point. If a certain thing happens, break. Okay? So we just use this word, break. Now, examples of where this might take place, you might be sorting over a load of files looking for a particular one file, and the program might run for a long time. And if that's the case, you might just run the break. You might say, if file found, break, and then just stop the for loop and then move to the next bit of the program. Okay, so that is topic 6, loops